Okay, so on your table, I put these blue sheets that have these classic polar curves on there. I'm giving this to you because we are not going to do the graphing of these interesting looking things in polar. We've got too much kind of to do as we go to finish. Plus, the polar stuff comes up calculus-wise in Calculus 2. So if you're taking AB next year, or you know, you're not going to be, as long as you're not going to be in BC next year, you're not going to see it next year. You know, if you're going to take Cal 2 at some point in college, or some other sort of, you know, mechanics or engineering class, the polar stuff may come up. It just probably won't come up for you hardcore next year anyway. But I want you to see them, and I want to, you know, kind of at least expose you to them, know what they're called. So we've got circles. We've graphed the circles, right? These right here that look like, they kind of look like, this one's a cardioid, and it's called, you know, because it kind of looks like a heart, it's just not pointy, right? This is, and by the way, this category is called limacon. It has this weird C, I don't know what the C is called, but limacon is how you say it. And yeah, there you go, that's what it is. And so you have this cardioid that looks like a heart. You have this one where it looks like the heart isn't as, you know, dimpled in, and then you have this one which just kind of looks like a wobbly circle, and then you have this one that has a loop, okay? Then you have roses that have 3 petals, 4 petals, 5 petals, and it tells you the number of petals you have is, it's n if n is odd. So if you have a 3 theta, there's 3 petals. If you have, it's 2n if n is even. So when you have a 2, it's 4 petals. When you have a 4, it's 8 petals. Okay, just, so you'll learn once you get, when you have to do the polar stuff eventually, and maybe not all of you would ever even have to, you just sort of learn what's happening. Then these are called limniscutes. Like Limp Biscuit, limniscutes, what it sounds like, it's how the way I remember it, or else I say it wrong. And then the spiral of Archimedes is pretty cool. So next week, I think we're either gonna give you an activity that you're gonna do like on your own, maybe as extra credit, or we might do it in class, haven't decided, where you kind of discover some of these, but I wanted you to at least see them and know what they are, and have this, you can just put it in your ISN. You're not gonna have to necessarily refer to it for anything, but it's just kind of letting you see and expose you to it. Yes? Yes. So this is going to go on page 128. And then the notes we've got for today are going on 129. Okay. Well, then you better go get it patented. You sure can. Why is it too late? Not everything, no. Okay, so we are going to, I want you to draw a little X and Y axis here. All right. And looks like this, all right? So we have an angle here, and I know there's not a whole lot of space, but this is theta, and you know, we know that theta revolves around that way, right? This is our X, this is our Y, this is our radius. That's an arrow there by my theta, by the way, showing that if you can't tell what it is, because I know it's kind of small. So here's some things that we know, just based on stuff we've done so far. I know by the Pythagorean theorem, which we learned in 7th grade, that x squared plus y squared equals r squared, right? In this particular picture, that's what's happening. Then I have 3 trig functions that go along with this as well, right? So if I want to do the cosine of theta for this particular triangle would be what over what? Adjacent over hypotenuse, so it would be x over r, right? And in our unit circle, r is 1. That's why the cosine is our x value. Make sense? And so then our sine theta is equal to what? Opposite over hypotenuse, so it's y over r. And when the radius is 1, that's why sine is just the y value when you're talking unit circle. Then tangent would be what? Good. Tangent of theta is opposite over adjacent, so that would give me y over x, right? And we talked about this a long time ago. That's how we came up with sine over cosine originally. So all of this just comes from that little triangle we just drew. So now I want you to look at this here. Let's say that I want to solve for x. If I solve for x right here, what would I do to make that happen? Multiply both sides by r, right? So I would get x equals r times cosine theta. Make sense? To get y by itself, I would multiply both sides by r, and I get y equals r sine theta, although I was about to write cosine. So, any of y'all in AP Physics? No? Okay. Because you do something in AP Physics, it's mg sine cosine theta, mg sine theta. That is what this is. Like that's what this is. And so it's the same type of thing. It's just not connected to this somehow. But what we're going to do is we're going to convert. We're going to convert from the polar coordinates that we just graphed on our quiz to rectangular coordinates. Because all these crazy graphs that you have right here, way easier to graph these in polar coordinates than it is in rectangular coordinates. Because, you know, having an equation that would do this, they're not functions, so the equations are weirder. But I could if I had to. And so we're going to be able to convert ordered pairs and convert equations eventually. So it says given a point P, so here's the point P, right? With polar coordinates r theta, the corresponding rectangular coordinates x, y are given. Well, this little triangle right here is what relates r, theta, x, and y all together, just by throwing that trig in there. So by doing all that, then what I know is, if I know r and theta to plot the points like we just did, I can find the x value because x is just equal to r cosine theta. And the y value is just r sine theta. So that means that your xy that you are used to is just the same as r cosine theta, r sine theta. Okay? That's all it is. Remember how we put xy equals cosine theta, sine theta? Remember when we did that? That was for the unit circle because r was 1. Well, when r isn't 1, then we have to throw r in there, and that's where it comes from. It's as simple as that. So it says convert each pair of polar coordinates to rectangular coordinates and round to the nearest hundredth if necessary. That's not going to be necessary because we're taking those questions off, so we're not rounding anything. That's why we didn't need a calculator. So we know that this is a polar coordinates for two reasons. First of all, because it tells us it is, and second of all, because we have an angle in there, right? So what this is right here, this is r theta, like we just plotted on the quiz. Yes? What I want is xy. Yes? So my x is going to be equal to r, which is 2, times the cosine of 5 pi thirds. And my y is going to be equal to the radius, which is 2, times the sine of 5 pi thirds. Okay. So then I have to know what these things are, right? So this is going to be equal to 2 times, what is the cosine of 5 pi thirds? So first things first. The reference angle is just pi thirds, right? So what's the cosine of pi thirds? 1/2, right? Okay, so then this 2 cosine of 5 pi thirds. 5 pi thirds is in which quadrant? Fourth. Because 6 pi thirds is 2 pi. So your pi thirds angles are pi thirds, 2 pi thirds, 4 pi thirds, and 5 pi thirds. So we're in the fourth quadrant. Is cosine positive or negative in the positive? So this is 2 times 1/2. So x is equal to 1. So then I do y. Y is equal to 2 times this, okay, sine of pi thirds. Well, what's the sine of pi thirds? Square root of 3 over 2. We're still in the fourth quadrant, so that means that it is negative. So this is negative square root of 3 over 2. So what does y equal? Negative square root of 3. Yes? So your ordered pair in the end then is 1 comma negative square root of 3. And we are done. Easy enough? And here's how you can check yourself, kind of. Not exactly, because you could still maybe be wrong. If I graphed this point as a polar point, which you don't have to do this every time, but if I did, right, then this point, 5 pi thirds, I'm in the fourth quadrant, and my radius is 2, so it's down here. When I plot this in the rectangular coordinate system, don't I go to the right one and down square root of 3? So I know I'm in the correct quadrant and things are good. Okay, we good with that? All right, let's do number 2. So I've got x equals negative 6 times the cosine of what? 3 pi fourths. And then y is equal to negative 6 times the sine of 3 pi fourths. We'll come back over here to x. So x equals negative 6. So cosine of pi fourths is what? Square root of 2 over 2. Square root of 2 over 2. And this is in which quadrant? Second quadrant, and cosine is what there? Negative. So this is negative square root of 2 over 2. So I know in the end x is going to be positive, right? And so I can multiply and make that 6 square root of 2 over 2, but can't I also reduce? And what is 6 divided by 2? 3. Please don't mess up on stuff like that, because that is such an easy way to mess things up completely. So then over here I get y equals negative 6. All right, so the sine of 3 pi fourths is also the square root of 2 over 2. In the second quadrant, sine is what? Positive. So this is a positive square root of 2 over 2, which means y equals negative 3 square root of 2. So this is 3 square root of 2, negative 3 square root of 2. And they're the same number, and that should make sense because this pi fourths is a 45-degree angle, right? So that means when I graph this, and again, you don't have to, I just wanted to make sure that you can make sense of this stuff. 3 pi fourths is in the second quadrant, but I got a negative radius, so I'm here, right? So I'm like, we're right there. And because this would be a 45-degree angle coming down, I have to go to the right 3 square root of 2 and then down 3 square root of 2. So the sides of the triangle are congruent to give me my 45, 45, 90 triangle. Okay? All right, we're going to do number 3, and then I'm going to let you do number 4. All right, so we're going to do x equals negative 1/4 times the cosine of negative pi halves, and y equals negative 1/4 times the sine of negative pi halves. Everybody okay with that? All right, so x equals, so we saw this negative 1/4. So I want the cosine of negative pi halves. What is that going to be? 0. Your negative pi halves is right here, right? So the cosine of this is 0. So I get negative 1/4 times 0, which means x equals what? 0. Then y equals negative 1/4. So the sine of negative pi halves is what? Negative 1. So this is y equals a positive 1/4. Your ordered pair is 0, 1/4. Okay? All right. You work on number 4. Should not be any decimals on your paper. Resist the urge. Notice I did not put 0.25 for 1/4. So negative 5 pi 6 is in which quadrant? Third. Okay, good. All right, so cosine of pi 6 is a square root of 3 over 2. In the third quadrant, cosine is negative, so this is negative square root of 3 over 2. Has nothing to do with the fact that that's negative, right? So I can't reduce anything. X is just negative 7 square root of 3 over 2, right? It's the best I can do there. For y, the sine of pi 6 is 1/2. In the third quadrant, it's negative, so it's negative 1/2. Which means y is equal to negative 7/2. Your ordered pair is negative 7 square root of 3 over 2, negative 7/2. Okay. Everybody okay with that? Any questions at all? All right. So before we flip over on the back, because we're not doing 6 and 6 and 6. We're not doing either 6. But I want you to look back up here at the top. Pi 15ths? I do not know off the top of my head. I would have to think about it. No, we're not doing that. That's why we're not doing that one. We use a calculator for it, yeah. All right, so notice for this, to convert from polar to rectangular, we used these two pieces of information that we came up with on the front. On the back, we're going to use these two pieces of information. Okay, so when we go to the back, I'm going to rewrite those two things. That's why I'm rewriting them, because we already figured them out up here. So on the back, we have x squared plus y squared equals r squared. And we still had tangent of theta equals what over what? Y over x, because it's like sine over cosine. Okay. So to convert it the other way, I have an xy that I'm used to using, and I need it in an r theta type situation. These are the two pieces of information we use, still coming from that triangle there. So it says, given the point P with the rectangular coordinates xy, the corresponding polar coordinates r theta are given by blank. Well, can I use this and figure out what r is? Yeah, what would I do? Take the square root? Yeah, so I would take the square root of both sides, so r is equal to the square root of x squared plus y squared. Does that just become x plus y? No, the plus is like glue, right? So that's how I find r. It's basically a Pythagorean theorem, right? So then I need theta. Well, if I know x and y, and I know that tangent is x over y, then how can I get theta by itself? Inverse. Good. So theta is equal to the tangent inverse of y over x. And that's what goes here. It's the tangent inverse of y over x. Okay. Everybody good so far? So far. All right. So the first thing we have to figure out is which quadrant we are in, because that's going to be important here. Because when you take the square root, don't you technically get a plus or minus? So I got to know if I want the plus or minus. So this right here, this 2 square root of 3, all right, what quadrant is this in? This is just an xy. It's positive, positive, so I'm in quadrant what? 1. Okay, so this is in quadrant 1. That's important for me to think about. So then I'm going to start by finding r. Well, r is equal to the square root of 2 squared plus 2 square root of 3 squared. Everybody good with that so far? So what is 2 squared? 4. When you square this, I highly suggest you don't use a calculator because you usually make more mistakes that way. It's really easy. You square the 2 and what do you get? 4. When you square the square root of 3, what do you get? 3. So it's 3 times 4, which is 12. So this is the square root of 16, and r is going to be equal to 4. And I know it's just 4 and a positive 4 because I'm in quadrant 1. Okay, does that make sense? All right, so then I'm going to find theta, right? So theta is equal to the tangent inverse of x, or of y over x. So it's 2 square root of 3 over 2. So what's 2 square root of 3 over 2? What is this just reduced to? It's just the square root of 3, right? So we don't even rewrite it. But I want the tangent inverse of the square root of 3.
So it's 3 over, square root of 3 over 3.
No. The tangent inverse of the square root of 3. It's pi thirds, because this only has 1 3 in it. If it was square root of 3 over 3, that would give me the pi 6. That's the 1 that's 2, yeah. So that means that theta is equal to pi thirds. So my answer then in an r theta situation is going to be 4 pi thirds, but it asks me to give 2. So notice it says convert each pair, round to the nearest hundredth. We're going to mark that out again because we're not going to do those. And then it says give 2 possible solutions if theta is between 0 and 2 pi. So theta is between 0 and 2 pi, but if this is my circle, right, here's my point. I'm at pi thirds 4, so I'm right here. So I have to have a positive angle to get here, or to get here eventually, but my radius could be negative, right? So I'd have to end up in the third quadrant. What's my third quadrant pi thirds angle? 4 pi thirds. I'd have 4 pi thirds, and my radius would be what? Negative 4. So I'd have negative 4 pi thirds, because it asks me for 2 there. Okay? Everybody okay with that so far? Ask me questions if you're not.
Okay, so the pi thirds and the 4 pi thirds, it can't be negative?
No, because of what this says right here. This says my angle has to be between 0 and 2 pi. When we were doing those other ones and we got some negative angles, it's because we were going from negative 2 pi to 2 pi, so we could get 4 answers. Does that make sense? We changed our domain there. Yes?
Okay, so if you got pi over 3, right?
Mm-hmm.
So if it was square root of 3 over 3, then it would have been pi 6, right?
Mm-hmm.
Okay.
All right. So let's look at this one. Let's jump to 9. So we're going to do r equals the square root of negative square root of 3 over 2, bless you, squared, plus negative 1/2 squared. Now, since we're squaring, do the negatives even matter?
No.
They really don't. So before I even do anything else, I forgot to talk about the quadrant. What quadrant are we in? Third, because it's negative, negative, right? So we're in the quadrant 3. So we're in quadrant 3. All right, so then I'm going to square this. So squaring your fractions is easy. You just square the top and you square the bottom. So the square root of 3 squared is what? 3. Over 2 squared, which is 4. Plus, what's 1/2 squared? 1/2 times 1/2. Come on. 1/4. Okay, 1/4. So what's 3/4 plus 1/4? 1. So this is equal to the square root of 1, so r equals 1. That's easy, right? So then we look at theta. So theta is equal to the tangent inverse of negative 1/2 over negative square root of 3 over 2. Okay? It's all good. Now, in the end, what's in the parentheses there is going to be positive. We agree with that? Yes. So this is going to be equal to the tangent inverse. Actually, we'll just come over here and do this. Negative 1/2 over negative square root of 3 over 2. That's the same thing as 1/2 times what? 2 over the square root of 3. Yes? And it's positive because of the, so those cancel out. That gives me 1 over the square root of 3. Rationalize. And when I rationalize, what is this? Square root of 3 over 3. So I get the tangent inverse of positive square root of 3 over 3. And what's that? Pi 6. Okay, so let's think about this for just a second, because we get pi 6. That is my answer, right, to this part of it. But I am looking for a point that's in quadrant 3. Is this in quadrant 3? No. So how do I get to, what would my quadrant 3 pi 6 angle be? 7 pi 6. So it's going to be 1, 7 pi 6. That's why the quadrant's important. You can't just use that angle, okay? And then I need I can use a negative radius, but I need another positive angle to get there. So if I'm here at 7 pi 6, I can also get there by going here, how much, and having a negative 1? Pi 6. Yeah. We okay with that? Questions? All right. I want you to, well, actually, we're going to do, okay, does number 8 freak you out when you think you have to square those things? Do I need to work through that with you? Maybe a little bit? It'd be nice? Okay. All right, so what quadrant is this in? This is in the 4th quadrant, right? So I'm in quadrant 4. Okay, Q4. So I'm going to do r equals the square root of, so I've got 3 square root of 2 over 2 squared plus negative 3 square root of 2 over 2 squared. Now remember, the negative doesn't matter when you square it, but you still have to write it down because that's part of you substituting it in. So then this gives me, when I square this one, I square the 3 and get what? 9. I square the square root of 2 and get 2. 2 times 9 is 18. So this gives me 18 over 2, right? When I square this one, what's this going to give me? Oh, 18 over 4. My goodness, thank you. I just wanted to see if y'all are paying attention. I know y'all don't believe that. Okay. 18 over 4. And then what happens when I square this? What do I get? The same thing. I get plus 18 over 4. It's still positive because I've squared it, right? And so I could reduce that, and it would have been okay to reduce it like beforehand, and that would have been fine. But I'm going to get, when you do this, you can do it one of 2 ways. Sometimes y'all reduce things like this, sometimes you don't. But isn't this just 9 halves plus 9 halves? And what's 9 halves plus 9 halves? What? Okay, let me do that differently then. Tell me what you would do. Would you reduce here or would you add first?
I added and
You would have added? Okay, that's fine. Okay, so we get, it's not 36 over 8. It's 36 over 4. That gives me the square root of 9, so what is R? 3. Okay, because there's lots of different ways you could reason through that. I just didn't want to make it harder. So we got R is 3. Yeah, that's fine. That's fine. Extra steps are fine. Other steps are fine. All right, so then we know that theta is equal to the tangent inverse of negative 3 square root of 2 over 2 over 3 square root of 2 over 2. Now, we can multiply by the reciprocal or whatnot, but do we need to? No, the numerator and denominator are identical. So what does it reduce to? 1. So this is really equal to the tangent inverse of a negative 1, right? That's a negative 1. So what's the tangent inverse of negative 1? It's, what, say it again? Negative pi fourths. It's a negative 1. 1 is pi fourths, but the negative 1, remember when you take the inverses, you have to go down here? So we get a negative pi fourths. Now here's the deal here. My theta can really only be between 0 and 2 pi. This is a fourth quadrant angle, right? And that's what I want, but I need the positive version of that, right? So what's that positive version? 7 pi fourths. So I would have 3, 7 pi fourths. And that's going to get me into that fourth quadrant, right? It's going to get me down here. But I need a negative 3, good, and 3 pi fourths. Y'all got the hang of it? Yep, good job. You got the hang of it. You can do it. All right, so the squaring on number 10 is not that bad because the numbers are pretty. So go ahead and do number 10. I want you to think about the quadrant and do all that kind of stuff, okay? Number 10, yes. What?
doesn't have square root.
It does. No, it doesn't.
Then what do you do when?
You skip.
Mm-hmm. No skipping, no.
Because the closest thing would be 8. Oh, and then you are reduced, right?
Mm-hmm.
Oh, yes.
I still don't know how to do that. 4 times.
Oh, both the kids.
No, I see 1. I hate the birthday.
What?
What? Wait, no.
36.
You see 1, you see 2.
Oh, I see.
I don't know what you see, and I don't know what you're talking about, but... Okay, guys, isn't this just 2 times 36? So it's 6 squared root of 2. Tangent inverse of 6 over negative 6. So that's the tangent inverse of negative 1, which is what we had up there too, right? This negative 6, 6, I'm in quadrant 2, right? So theta is equal to a negative pi fourths. But I want it in the second quadrant, and tangent is negative in the second quadrant. So what's my pi fourths angle in the second quadrant? 3 pi fourths. So it's 6 squared root of 2, 3 pi fourths. And then it is negative 6 squared root of 2, what? 7 pi fourths. Okay. Ask me questions if you got questions. Good, I'm glad you're learning. On the assignment, so that I don't forget before the bell rings. You are omitting 2, so grab your assignment so I can tell you what to omit. You're omitting numbers 4 and 8. There's only one side, and you're omitting 4 and 8 because those require a calculator. We don't need to do that. You don't need a calculator. You need to do all this stuff by hand. Okay. All right. Are we good? Yeah, you do just 4 and 8. Just 4 and 8. What'd you say about number 2? Don't put words in my mouth. 4 and 8. No. All right. You can do it.